Welcome back. So now we're going to take a look at the position time graph where we see most of our data are below zero. Okay, so this graph is just the same graph as the previous video, but is now inverted, where most of the information that was in the positive is now in the negative. Okay, so today we're going to look at creating a story, which is just my example as I explain the graph. We're going to look at distance and displacement at each region. So we have one, two, three, four sections of the graph. We're going to look at distance and displacement and for each section, and then we're going to look at the overall distance and displacement as well as calculating speed and velocity for the entire trip. Okay, so 0, 0 is our starting point. So the story is going to say we are at home. Home is going to be our base point. Okay. The fact that we start moving away from zero, but in the negative area means that we're just only traveling in a negative direction. Negative doesn't necessarily mean bad, it's just not positive. So in our case, normally a negative direction is to the left or below or down. Okay. That can also be your west and your south direction. So we're at 0, 0. We're at home. We walk outside to the end of our driveway. We look to the left and we start walking. We are walking for this first section. We walk 60 meters. How do I know we walk 60 meters? I'm looking at my y-axis here. Now, it says negative. Negative only indicates the direction. So we walk 60 meters to the left of our house. So that means our distance so far is 60 meters. Displacement looks at where you end and where you started. So in this section, we ended at negative 60 meters away from the house. Negative 60 means 60 meters to the left. So we're just going to put the negative here because we're going to use it in our calculations later on. Once we're 60 meters away from the house, within 10 seconds, we see our elderly neighbor who is outside watering her lawn, and we just wave. For 5 seconds, we're not moving because we're just standing there waving and talking to the neighbor. So this means our distance for number two is 0 meters. Displacement is also zero. And please do not forget your units. We're doing meters. Okay. So we're not moving. There's no change in our distance. So in between 10 and 15 seconds, we are still 60 meters away from the house. After we talk to the neighbor for those few seconds, we realize, hey, I think I went the wrong way. I was supposed to go to the store. So now we're going to turn around and we're going to head back home. So if we were originally traveling left and we stopped and talked to the neighbor, that means we are now traveling in the opposite direction, which is to the right. The reason why we don't have this portion in the positive side of the graph is because we're still to the left of our house. Right now, we're just decreasing that distance. Remember, your house is zero. So we go from negative 60 meters, negative 40, negative 20. Now, boom, we're right at our house. Okay. we continue walking in the right direction, in our positive direction. We just passed up the house now, 20 meters, 40 meters. Now we're at the store. 40 meters past our house in the right direction. And I'm pointing to my right. Not sure how it looks in the camera in your view, but I am pointing now to my right. So now we're at the store. So let's calculate the distance that we traveled from the neighbor's house that we stopped and waved to. We passed up our house going in the right direction, meaning the positive direction, even though we're still to the left of our house. Once we made it past, once we made it to the house, we're at the zero mark. Now we're going to continue our journey in the positive direction. This is just us walking back and forth. So we go from negative 60 to 40. And I'm just looking at the numbers that's on my graph. So my distance will be the total amount traveled. So we got 60, then we go to 40, that's 20, 40, that's 60. 60 to 0 is 60. Then we go an additional 40. So section 3, the distance is 100 meters. Your displacement, remember, you're subtracting where you end minus where you started. So let me do this displacement down here so you can see the math. We ended at 40 meters. We subtract where we started for section 3, which is negative 60. And remember, going all the way back to basic math, when you subtract a negative, you are adding. So our displacement is also 100, but it's positive, right? Because this whole entire line, even though you have part of it in the negative and part in the positive, we're still traveling overall in the positive direction. Okay, so that's why my displacement is a positive 100. Last section, we leave the store and we come back home to our house. We're back at 0. So my distance for section number 4, I'm going to put the 0 behind here for 40. That is my distance. My displacement is also 40, but look at the slope. We are decreasing our distance to go back home. We are decreasing the distance, and we're traveling in that negative direction. So remember, the store was already to the right of our house based on section 3 of the graph. Now we turned around and head towards home. So this is going to be negative 40 meters. Okay, do we understand? If you're in the negative at the bottom, that just lets you know the direction that your object is in based on your home position. Okay, based on your home position. So just make sure you have a focal point for your home position when you're dealing with the graph. Then you can understand how the object is moving based on your home position. Okay? Now let's look at the total distance traveled. When you hear the word total or you see the word total, that means to add. Distance is the easiest one. We're going to add the distance or the D's that you see and add them all together. So we have 60 140, which is 100, plus 100 is 200, plus 0 is 200. Okay? Displacement. You look at where you started and where you ended. So you look at the distance between where you end minus where you start. Two ways we can do that. First way, we can just look at the graph. Where did we end? 0. Where did we start? 0. 0 minus 0 is 0. So overall, if somebody was not paying attention to your journey, they're going to think you did not go anywhere because where they left you is where they found you. Where you ended your journey is where you started. Another way is to add up all the x values that you see. Well, let's do that. Negative 60 plus a negative 40. When you add a negative 60 plus a negative 40, when you add a negative, it all becomes subtraction. So this becomes negative 60 minus 40, which is a negative 100. So negative 100 plus this positive 100 is 0 plus this last 0 is 0. You will also see questions with the graph that asks for speed and velocity. And yes, you have already seen this before, and you will also see this again later on this week. You may see something that asks for the average speed. When you see average speed or average velocity, you would need the total distance divided by the total time of the trip. So that would be 200 over 55. And I will get my calculator. 3.64. My units for speed. Since we're dividing the numbers, we divide the units. For distance, our units is meters. So that's M divided by the time unit is seconds. So our average speed throughout this whole journey with the total distance of 200 divided by the total time of 55 seconds, we get 3.64 meters per second. If they ask for average velocity, we use displacement, which is the x, and that would be 0 over 55 seconds, which would be 0 meters per second. And since we ended where we started, we don't have a direction in our answer, and that's for overall. If they want specific speeds and velocities, like at different time segments, then you look at how much time has passed between those time segments and the distance, and you do the same calculation. I hope you were able to understand the lesson. If not, you will have more practice and more videos and more resources, and you also have tutorials with your teachers. So please utilize the help that is given. Thank you.